Our closest exoplanet has now been confirmed. Proxima B is roughly 4.2 light years away, and it's today's Talkin' Science Story of the Week.
Across Apple Podcasts, Spotify, Google Podcasts and YouTube, this is Talking Science with Dr. Brad Tucker and Matt Miller.
We're from a few billion light years away to just a handful. Brad, astronomers have confirmed the size and generally that it's there. Proxima B, our closest exoplanet.
Yeah, and this is something that happened back in 2016, the announcement that there was an exoplanet around Proxima Centauri, the third star of the Alpha Centauri system, that system that's only 4.2 light years away. And people believed that there was an exoplanet, but you A, always want confirmation, but B, a better measurement to actually measure the properties of it. And this new instrument, Espresso, which we've talked about in other cases, it was used for discovering the nearest black hole, as we talked about a few weeks ago, was able to pinpoint the exact size of this exoplanet, it being 1.17 times the mass of our Earth. So pretty similar in terms of size. It's actually closer in size to us than Mars is.
Having said it's pretty close in size, it's not. It's nowhere near close in terms of its orbit around the star. It's going around pretty quick, about every 11.2 Earth days.
It is. It's a very fast orbit, and this is kind of one of the interesting things that we start to see is we can see the mass of the planet or the size, but then the question is, what are the other properties like? So it's orbiting a red dwarf star. So this is a star much cooler than our own sun. So that means by orbiting close, it's not as saying, you can imagine Mercury orbits our sun every 88 days. So this is much closer than Mercury. You would say, oh, that's really hot, but the star is so much smaller and cooler that temperature range then shrinks, and also the habitability range shrink, and the habitable zone shrinks. So, it moves proportionately. It was always believed to be something we call tidally locked, and that is one side is stuck facing the star. It's the same thing as our moon. There's always one side that faces us. So we only see one side of the moon. Not that it's a dark side or a light side. There's just one side that we can see that sometimes gets light and dark. And so if you have a planet like that, you always have one side in daytime and one side in nighttime. Very different system than our own planet.
Now, while it is located within the habitable zone, which means that there is potential for liquid water and maybe some life, the fact that Proxima Centauri is an active star releasing about 400 times more X-rays than we get from our star, it's more than likely that this planet is just hanging out in close orbit.
The other way I say it is, if there is life on there, we don't want to mess with it because we can't kill it. It's a better wish than not. But that's exactly right. There's more than just the size and the orbit of the planet. And this is really, we've talked about this a few times now, what all these new discoveries are about is not just pinpointing the size or its orbit, but, what is it? What is its rotation like? What is the host star like? It's measuring the system as a whole. Because as you said, if this planet and one side of the planet in particular, the side with daytime, is just bombarded by radiation constantly, you just can't survive that in any way, shape, or form that we think, right? That we think we can manage. It just becomes completely impossible. It's not to say that it's impossible, but in the way we understand life and evolution, it doesn't seem to be the case. And so it's more of just finding these planets, it's finding the whole system. And that's really what a lot of projects, especially here in Australia, are about, measuring the star and the planet, putting that picture together. Because if you discovered our planet exactly, imagine our planet, but the sun was very different, or we didn't have a sun, or the sun was a red giant or a red dwarf, this life on this planet would be very different.
And interestingly, there's some Hubble data from about 25 years ago suggesting or helping to suggest that there's the potential for 2 more planets in this system.
That's right. Proxima Centauri has been imaged a long time because it is the closest star. That is one of the benefits of this planetary system, even if it's not habitable or anything like that. It's just close, so it's just easy to study. That's the benefit. And as you said, the data from Espresso and Hubble Space Telescope has hinted at maybe 1 or 2 other planets in the system. Again, just showing that it's not just a or one planet around a star. There's multi-planet systems are almost the norm, that there's a lot of these things going around. And again, these planets have to be confirmed. And what those planets are like are very different, because they tend to be hinting that they're a bit further out. And therefore, the issues relative to Proxima Centauri B would be a bit very different. So it's an interesting time in exoplanets, and it's going to keep going like this for the next decade. And this is exactly what the whole goal of TESS, the Transiting Exoplanet Survey Satellite, trying to do. Kepler, the new Kepler Space Telescope, is just looking at all the nearby stars to find the planets. Because if planets are so common, we don't need to go look. We don't need to try hard. So let's just get the easy picking fruit, because that's the ones we should focus on.
Absolutely, Brad. Well, speaking of picking fruit, I say it every week now, but it is fun to pick apart the stories of the week with you. Yeah, there's 2 puns this week. I've got a chuckle out of one of them at least.
No, that's right. You got to get the third so you can get the trifecta. Pressure's on.
Can't think of it before we close the show.
Under pressure.
Can I put a pin in it and come back to it next week?
There we go. All right, that's right. We'll try for 3 next week.
Fantastic, Brad. We'll catch you then.
Take it easy.